Hello and welcome back. In this session, we will deal with few concepts that we require to have a basic understanding before we proceed with the rest of the examples and exercises. So the first concept, which is a basic building block of an image, is called as a pixel. So pixel can be called as a picture element. So it's a smallest unit of a digital image. You can see this is an image, and if you zoom this image to a particular level, at some point it cannot be zoomed further because this will be the basic element. This square will be the basic element of this pixel. So this picture is actually composed of many squares like this, and since we didn't zoom this picture, we cannot identify it. For example, if this image is of height 500 and width 300, then we have 500 rows of pixels going down and 300 columns of pixels going on to the right side. So this will be a grid of pixels, and the total number of pixels will be just like we calculate the area of a rectangle, length into breadth. Just like that, the area will be the number of pixels lengthwise or breadthwise into the number of pixels lengthwise, or vice versa. So this will give the area. That area will be the number of pixels inside the image. And talking about type of pixels, we have two types of pixels. Images are two types. We have color images and we have gray images, that is black and white images. So pixels are also like the same. There are two types: grayscale pixel and color or chromatic pixels. Grayscale pixel actually have the value from white to dark, which will vary from intensity. Here it's white going all the way to dark. So grayscale picture can take values from 0 to 255. So when it's 0, it will be a black pixel, and when it's 255, it will be a white pixel. So in between this 0 and 255, maybe 150 or 120, there will be a small shade of gray, and going on to the top, if it's a 200, then the gray will be a bit darker, but there will not be any color, only white and black. And then comes the color pixel. Color pixels are actually having three basic colors, which can be represented as a tuple. Tuple, just like an array, we can have three values saved in consecutive in an orderly form. So the color pixels value is saved inside a tuple. The tuple consists of three values: red, green and blue. So every color which can be formed by a color pixel can be represented as a combination of red, green and blue colors. Mixing of these colors in different intensity will generate different color. So in order to represent a color pixel, we need to have three values. That's mandatory, because the color of the pixel, what exactly is the color of the pixel, is determined by the intensity of red, green and blue. But in case of grayscale, we need only one value, because the intensity of black actually determines what exactly is the color of the pixel. For example, we have three basic colors here: red all the way from 0, which is no red color, to full red color, and green, which we have from 0 to full green, and blue, which we have from 0 blue to full blue. And here you can see this color, the cyan color, is being generated by combining green and blue. So green with blue combine together to form this color, then red and blue combine together to form this color, then red and green combine together to form this color. And if you are changing the values further, for example, green, if we add 100, it will be another color. Here also, if we have green, if you reduce green, or if you reduce red to 50, then it will be some other color. So infinite combination of colors. So an almost infinite combination of colors can be generated by three basic colors. In case of grayscale, you can see that we have black color, we have white color, and the combination of, and using this color pixels, we can generate grayscale pixel also. So concept is simple, old school physics. Combination of colors will give another color. Primary colors combine together to form secondary color. Stuff like that. And this is how we represent colors in tuples. As we know, tuple is actually a format in which we can save. Here we are talking about three values. The three are red, green and blue values. These three values are saved in a sequential form inside a tuple. And just like we discussed before, to construct a white color we need to fill the tuple. That is, the value of three colors should be 255. And if we require a black color, then we have to empty the bucket. You have to remove the color. Just remove all the three color values and it will be a black color. Then to generate individual primary colors, you can have each value to its maximum value so that primary colors can be generated. And in order to generate secondary colors like this, you can combine the red, green and blue values and it will generate multiple kind of color output. So hope we are clear about the color concept. Now let's move on to representing coordinates inside an image. In our first slide we see that this is an image and it is represented inside an X, Y plane. Just like that, if this is an image drawn inside a graph, in a graph paper, you can see that the axis that is going down will be a Y axis and the axis that going right is an X axis. So we assume that our image is placed inside this graph paper and each point inside the image can be represented by using the X and Y values. For example, the value at 0y and 0x is this one. The value at 18x and 6y can be represented like this. That's a pixel at 1816. And here's another pixel where the x value is 6 and the y value is 13. So if you plot our picture inside a graph paper like this, we can refer to every point of the picture using this kind of a reference point. And here is an example where the letter I is placed inside a graph paper. We were just plotting points here, but in this example we have a letter called I. You can see this is a zoomed in version of the letter I, which is represented inside a graph paper. You can see that there's the points that require to be darkened are marked here. You can see 0, 0, this is a point, this will be 1, 0, 1, 2, 3. And of course, one thing to remember, the counting will start from 0, not 1. Actually, since this is a pixel, so make sure that you keep in mind that the calculation will be starting from 0 and not from 1. Here also it's the same. We have it from 0 and this pixel will be 0, 1, 2, 3 to x and 0, 1, 2, 3, 4 to the y. So 3 to the x and 4 to the y, this is a point. That's all. I think you are now clear about how images can be represented inside a graphical plane and how we can refer to the points inside the image using x and y axis. And since Python is 0 indexed, just like I said before, the counting will start from 0 rather than from 1. And that's all in this session. In the next session, we will write a simple opencv program and we will load an image and execute everything inside the opencv program. So see you soon in the next session. Have a great time. Bye bye.